But I think all of this work, it all depends on the information we have. We also have to work on this basic level. So our next presentation is from Germany. Monitoring during life cycle of bridges to establish performance indicators by Peter Hart and Ralf Holst, presented by Ralf Holst. You know that Germany is one of the few countries where the maintenance budget has been increased. I think all the other countries went down. Okay.
Thank you very much for a kind introduction. A warm welcome from my side and also from my colleague Peter Hart. Unfortunately, he's not be able to attend here because of other appointments. But this presentation is mostly based on his work in his section, because he is. We are also in the same department of bridges and structural technology at BAST. I'm in the section of maintenance of engineering structures and involved in bridge inspection and the normal visual bridge inspection. And he's involved in our topic, smart bridges and sensing technologies. So, what I want to talk about a little bit about the background in Germany. One was the background that the fundamental basis, the financial bases are increasing, but in the future we will get an infrastructure company, and that can be a problem, maybe, because we have to deal with this. We have to rebuild, we have to maintain our bridge stock. So, what is the background of aging infrastructure? It's similar to everybody who are here. We have an increase in traffic. We have also especially heavy traffic. In Germany we have 44 tons. In special cases we have 100-ton trucks and something like this. We have the boundary. Our bridge inspection is a very good bridge inspection for visual bridge inspection, but it has boundaries. It has a limited access to only for visual damages, no on limited information from inside of the structure, maybe with non-destructive testing, but this is not part of normal bridge inspection. And we have information only to a certain point in time and not continuously. In some cases we need more information and for a longer time, but normally we have just for one special time. And the complex behavior of our structures, especially our bridges, every bridge is a special type for us. It's very difficult, so key performance indicators are necessary, and that's why I'm involved in 1406 and Peter Hart are involved in 1402. In Germany we have regulations for everything, and our basic regulation is the German standard DIN 1076. There it's mandatory to make bridge inspection every 6 years for every bridge in Germany. A major bridge inspection 3 years after this, a minor bridge inspection. The second part is our guideline. We prove there. We have the guideline for the recording, assessment of damages, and the condition assessment. This is mandatory for our main roads and for the state roads, not for communal roads. They can use, but they don't must use. Then we have a database, and ASB is our basis for the database, and the important part, the new part, is a guideline for recalculation. Since 2011 we have a guideline for recalculation in Germany, because we found out that the Eurocodes are not useful for the recalculation of existing bridges, because in this cases we all had to replace our bridges, and that's not possible. So since 2011 we have a guideline and one update last year for this recalculation. As I just mentioned before, a guideline for the assessment. In Germany we make evaluation on component levels, the substructure, bearings, around about 14, 15 components for a bridge. And we make a damage assessment for every damage regarding stability, traffic safety and durability. And therefore a program based on this matrix is only one table. We have 6 tables for different cases. The condition index of the component levels and for the total bridge is evaluated, calculated, and based on our database. In Germany, we have one database for every 16 states. I just have to mention that in Germany, the owner of the A and the B roads, and that are the highest level of roads, are the Federal Ministry of Transportation, but the 60 federal states have to do the operation. They have to plan, they have to build, they have to make inspection. Our data that we have at BUS comes from the federal states, and they do this bridge inspection. I just mentioned before, we have also a guideline for recalculation for existing bridges, for special types, with 4 levels. The level 1 is the calculation based on the normal Eurocode level, or in Germany we call it DIN-Fachbericht. Now it was just some years ago, now we all have to calculate regarding the Eurocodes. The level 2 is consideration on supplementary regulations for special cases for the bridge itself, so that we can reduce in some cases the safety factors. The level 3 is consideration of measurement results, measurements at the bridge itself to see whether the behavior is similar to what we expect or whether maybe it is better, and then we can reduce also the safety factors. And the level 4 is including new scientific methods to see whether we can increase the residual lifetime of the bridge for the planning of a new bridge or something like this. Yes, and one topic in this guideline is the possibility of compensation method, maybe monitoring to see how is the behavior and not to close the bridge or to reduce the load carrying capacity. And that's the reason for this presentation. Key performance indicators in Germany we have, I just mentioned before, the condition index of our bridge, the condition index of the components, and the load bearing capacity and the military load class, as we call it in Germany. And the evaluation criteria I just mentioned before are traffic safety, structural safety, and the durability itself. We also need measurable indicators to describe these key performance indicators. These are normally every bridge has tracks with width and length, more or less, corrosion of the reinforcement, or for steel bridges, but I mostly mentioned concrete structures because in Germany we have around about 80-85% of our bridge stock of the A and B roads are pre-stressed or reinforced concrete bridges. Also deformation are important to know and to see whether it can be a key performance indicators. The strength of the concrete, the strength of the reinforcement. Flakings are obvious a problem, and because we are at roads, chloride that is also a problem and not normally measured at our bridge inspection, our regular bridge inspection. So we need further information from more monitoring or something like this. Yes. The next slide, I want to mention methods how we can use in Germany, how we want it, and how we do use monitoring, maybe in this case for quality assurance and function checks. Calculation, the service life can be possible because only with a normal bridge inspection and this data from every 6 years or every 3 years, it's not possible and not very easy to calculate the service life. There we want to use monitoring, especially when we have a reduction of the load carrying capacity or other severe damages. We do permanent monitoring of critical areas, not for normal bridges, but when we have critical areas and we have to reduce, I just mentioned before, load carrying capacity. We make monitoring. We also make monitoring for inaccessible areas because there is no possibility made visual inspection, survey of bridge reaction, how it reacts under loads, under temperature, and something like this. And also the assessment to evaluate the structural measures itself, whether when we stiffen or strengthen our bridge, how the reaction of the structure is. And the key performance indicators in this case is also our condition index and the load carrying capacity before and after the monitoring, before and after the structural measures. Monitoring of actions, of impacts is also a very important and useful task for monitoring, because we want to know the traffic load reaction, the exact traffic load reaction of our bridge itself. And we want to know what is the load spectrum at this special bridge, what are the axle loads, what are the vehicle loads, maybe in some cases for steel bridges more obvious than for concrete bridges, the vibration coefficient, climate, temperature, and something like this. The intensity, in some cases we make weight in motion to see how the intensity of our load spectrum is. And we make it on the bridge itself and on the components. Expansion joints in Germany. In one case for the smart bridge near Nuremberg in Germany, we have placed an expansion joint combined with monitoring in a bridge, also a bearing combined with monitoring. It's just started, I think, 3 months ago, and we want to see how the behavior of this bridge will be in the future. And permanent measurements of strains to make the influence line to see whether the behavior of the bridge is appropriate or not. And here are the key performance indicators, the deformation, the strength itself, and the cracks, how they and when they open and when they close. Monitoring of condition, deformation of the deck is obvious that we can and we do measure this deformation. The moisture penetration, because when the pavement or the ceiling layer is destroyed, we can see whether there is moisture inside the crack and the crack width itself, flaking with exposed reinforcement and reduced cross sections, the depth of the chloride increase, and also moisture penetration I just mentioned before. Here we use the KPIs also mentioned before, deformation, the cracks, the flaking, the chloride gaps, and the change in deformations, e.g., for example, for the cross section itself. Yes, monitoring of safety-related system itself. We want to have an early warning function for this special topic to see whether changes we are not thought about. We want to set limit states, thresholds, to have a warning system to give a signal to your smartphone or something like this. We want to have a non-destructive online analysis to see what is the behavior, not at present, but over a certain period of time. And therefore we have two strategies. One is, just mentioned before, earlier this morning, two strategies, a predictive strategy to see and make an adaptive model of our system, and also on the other hand we define thresholds and to see whether our system reaches our thresholds or they don't reach this threshold. This is in continuous monitoring. And monitoring and also of safety-related system elements, the threshold values. That's very difficult to have the right connection between the zero state. Normally we have not the zero state because the beginning of the bridge we don't know normally, but 20, 30 years after this we have a problem at that bridge, and then we want to measure, and then it's not too easy to get to this zero state and therefore to define the target value. It's also not so easy to make a realistic simulation of the damages and the bond behavior of the reinforced concrete and the bridge itself. In some cases, it's possible for the recalculation. In some cases in Germany, the federal states, the road administrations do this evaluation, and it shows very good results, but it's a great effort to do this. We need, for this case, plausibility checks to control the redundant of the measurement procedure itself. And it's not so easy to implement or to see what is the physical model and how to implement this. For the final element model, updating is one topic in this case, but we see in special cases we can use it, but it's very difficult to use. But maybe in some time before we have to close, or the Federal Road Administration have to close the bridges, we have to deal with this topic. On one hand, we have the physical models. On the other hand, also one part of the, I just mentioned before, the topic of research cluster smart bridge is non-physical models. When we want to train our systems to see when there are differences in the behavior of our structure. This needs a lot of data, and we need a lot of time for this training. In some cases, it works well. In other cases, it's not so good. So that it is also a topic for research, but it has a great possibility for the future, because in the aviation area or in the automotive area, this is normal that they use this kind of training and learning techniques. So we have to do it for our section also. And I just mentioned at slide 2 or 3, we also use monitoring as compensation measure according to NRR as our recalculation guideline. In Germany we have one special bridge near Cologne where we have to reduce the traffic, especially the heavy load traffic, because of the severe damages. And there also in this guideline we have the possibility to keep this bridge also under operation, but to reduce some loads and to see how the behavior is. But for this we need more detailed information from monitoring or non-destructive testing or something like this. And here for the KPIs are the limit state of the bridge we have, or the Federal Roads Administration have to calculate this, the compression, the crack width, the shear strength, the load carrying capacity before and after. And for steel bridges, I just mentioned the bridge near Cologne, it's a steel bridge over the Rhine. There we have fatigue problems, and in some cases crack corrosion problems. So we do monitoring in Germany for special cases. I hope in the future we can do it more, because we have to deal with the possibilities of monitoring because of the severe problems of our bridge stock in Germany. Therefore, we have this cluster smart bridges, and we have also Durabus. It's a testing field, Cologne, near the bus, where we also have an existing bridge instrumented with sensors, and we are now in the next month want to start this program and to see what different sensors we can use, because it's an existing bridge, but without the normal traffic, but it belongs to the normal bridge, the A3 near Cologne. That's what I was to show about our approach in this area. Further questions?
Thank you very much. Are there any questions? Immediate questions?
How often do you use this monitoring to enhance your assessment of bridges?
Not very often in Germany. I think in Germany we have on the federal road around about 50,000 bridges, and I think we make monitoring on 100. But in the future, I think those are
Is that 100 a year or 100 totally?
totally.
Yeah. You have been doing on for some 10 years. I mean, how many bridges are the year that you start monitoring?
Sorry?
How many bridges do you start to monitor each year?
Each year? Yes. In total, I think 40 to 50 bridges in Germany. But I hope we want to increase this because we have to know more about the situation. And as just mentioned before, the financial resources are increasing, so that we have to know more about the bridge. Okay.
Maybe a short intermediate question. You know that German railways already ask for building information models for new bridges. Is there any intention on the road bridges too?
Yes, our federal ministry started a program on some topics, two bridges for the railways and one tunnel, road tunnel and one road bridge. And we at Federal Road Administration also deal with this building information modeling because we want to see what are the advantages for our side. I think this will start, this will come, we have to deal with it. Yeah.
Any other question? Immediate question? It's well worth looking at Germany. You know, it takes a long time until Germany starts doing these things, but when they do it, they really, the train is running. Okay, thanks again.